गुड मॉर्निंग। आज तो
सर, वेरी गुड मॉर्निंग सर।
ठंडा नहीं पड़ रहा है, आप कुछ पहने नहीं है।
सर इतना नहीं है, अभी यहाँ पे गर्मी है।
गर्मी है।
हाँ, मतलब
अभी
सुबह
तो
शाम
लोग।
ठंड है।
अच्छा। सुबह शाम की
हालांकि अभी
ठंड।
अभी एसी की जरूरत ना हो, अभी एसी की जरूरत नहीं है यहाँ पे दिल्ली में।
एसी कहाँ चला रहा है कोई, इस समय थोड़ा नहीं एसी चलता है।
बिल्कुल सर। हम्म, हम्म।
सुबह शाम ही जो है कोई शर्ट पहन के 2 घंटा टहल ले, तबीयत खराब हो जाएगी।
हाँ, चांस है, ठंड लगने का चांस है। बिल्कुल।
और क्या समाचार।
तो आपका आशीर्वाद है सर।
क्या टॉपिक है आज का।
सर आज गैस मीटर, बिकॉज अभी हम लोग रेगुलेट कर रहे हैं गैस मीटर को।
हम्म,
तो उसके लिए गैस मीटर के ऊपर आज ये है प्रोफेसर पांडे साहब अपने रांची से, इनका
रांची
लेक्चर है।
से रांची।
जी।
पांडे जी नमस्कार।
सर नमस्ते सर, कैसे हैं सर?
बढ़िया बढ़िया है।
स्वास्थ्य ठीक है सर?
बढ़िया। हाँ ठीक है।
बहुत दिन बाद सर आपको देख के बहुत अच्छा लगा।
मतलब सर इज
हाँ
ऑलवेज अवेलेबल ऑन एवरी सैटरडे। यू कैन मीट
सर
ऑन
सर
एवरी सैटरडे।
सर 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 सर
हर सैटरडे को आता हूँ जो है।
जी सर, जी सर, जी सर।
आज तो प्रधानमंत्री जी बनारस में है।
हाँ सर।
रेल यात्रा का है।
जा रहे हैं आप?
रेल यात्रा। हम्म।
जाएंगे आप?
अरे उनका हो गया, उद्घाटन हो गया।
अच्छा, उद्घाटन हो गया, वेरी गुड।
वो बिहार चुनाव से आए हैं थोड़ी देर के लिए, 16 घंटे के लिए।
अच्छा।
तो उनके बहुत से कार्यक्रम है, उसमें जाएंगे।
जी।
अब पार्टी मीटिंगों में जाएंगे।
जी।
उद्घाटन तो कर दिए, ट्रेन को हरी झंडी दिखा दी।
ठीक, वेरी गुड।
बनारस को उन्होंने बहुत कॉस्टली बना दिया है।
जी। बहुत
यहाँ
अच्छा।
की जमीनों की बहुत ज्यादा हो गई, दिल्ली से भी ज्यादा हो गई।
ओहो, अच्छा।
हम्म, बहुत ज्यादा हो गई।
हम्म।
करोड़ों रुपए में विसा मिल रहा है, ये तो मतलब थोड़ा। सारनाथ में है, मैं तो थोड़ा आउटसाइड है, वहाँ की स्थिति है। एक
अच्छा।
करोड़ से ज्यादा।
माय गॉड।
केवल लैंड कास्ट, जमीन बिल्डिंग कास्ट तो बहुत ज्यादा महंगी है।
माय गॉड, वेरी डिफिकल्ट सर, वेरी डिफिकल्ट।
हम्म। हमारे बगल में 3 बिस्सा जमीन बिकी है। 3 लोगों ने 1-1 करोड़ में लिया है जमीन।
ओ माय गॉड। एक बीघा में कितना होता है, कितने स्क्वायर मीटर होता है सर?
करीब 1300 कुछ स्क्वायर फीट होता है।
अच्छा, 1300 स्क्वायर मीटर नहीं, अबाउट 100 मीटर स्क्वायर मीटर।
100।
वेरी कॉस्टली, वेरी कॉस्टली।
लोगों ने बना दिया, क्या किया जाए। पता नहीं कहाँ से लोग इन्वेस्ट कर रहे हैं, इतने बड़े बड़े होटल खुल रहे हैं, इतने बड़े बड़े कि आप सोच नहीं सकते हैं कि ये पैसा कहाँ से आया है।
माय गॉड।
सब जगह बड़े बड़े होटल, अन्य चीजें तमाम यही सब खुल रही हैं। और बाकी पब्लिक गरीब है जो। ये भी कितना दुर्भाग्य है नहीं।
ट्रू। ट्रू। टू मच डिस्पैरिटी ना।
हाँ आशुतोष जी, आवाज नहीं जा रही क्या?
सर आ रही है, बिल्कुल आवाज आ रही है सर।
तो आपने आरएसएल और रांची में सब टेस्टिंग फैसिलिटी वगैरह क्रिएट कराया?
सर बस हो रहा है, फाइनल हो रहा है। आई होप वेरी सून विद इन ए ईयर इट विल बी डेवलप्ड। We have already made the plan. We have already finalized with NPL. Maybe by the within a
एनपीएल
year
से
it will.
किया है, लेकिन सबसे जरूरी है कि अपने आरएसएल वगैरह में, रांची वगैरह में
जी सर, हो जाएगा सर, एक साल के
सब
अंदर हो
जगह,
जाएगा। जी सर।
सब जगह आप आखिरकार स्टैंपिंग तो इंस्पेक्टर के द्वारा ही कराइएगा ना?
जी जी जी। नहीं सर, जो गैस मीटर्स हैं, एनर्जी मीटर्स हैं, प्लस ब्लड प्रेशर मीटर, थर्मामीटर, ये वाटर मीटर, आई थिंक ये तो सर प्राइवेट जीएटीसीज भी कर सकते हैं। बिकॉज सर अदरवाइज वी डोंट हैव दिस मच इंफ्रा विद द स्टेट, वी हैव वेरी फ्यू ऑफिसर्स।
वो तो ट्रू है, तो सत्य बात है, सारी दुनिया जानती है।
जी।
लेकिन कानून में आपने इतना शक्तिशाली लोगों को बना दिया है कि सारी मतलब शक्तियां जो है वहां ही देखती हैं, कोई काम करने से डरती हैं।
नहीं सर, अभी ऐसा नहीं है। नाउ वी हैव मेड अ लॉट ऑफ वी हैव मेड लॉट ऑफ चेंजेस। इवन यू रिमेंबर व्हेन यू वर देयर, few of the provisions we decriminalized at that time, and again now we are decriminalizing most of the provisions.
सब प्रोविजन डिक्रिमिनलाइज कर दिया जाएगा, तब भी उसके पास इतना पावर है कि शटर बंद कर देगा, तो आप क्या करिएगा?
Nowadays it is not happening sir.
अरे भाई, आप वे ब्रिज की टेस्टिंग का हाल जानते हैं, वो तो मतलब ये सब जो है, जब कारखाने में कोई पहुंच जाता है तो बड़ा मुश्किल होता है। इसलिए स्टेट गवर्नमेंट इन लोगों को मना करती है कि आप लोग कारखाने में जाइएगा ही नहीं, अपने ऑफिस में बैठिए।
अच्छा।
हम्म। नहीं, जिस कंपनी का 5 पेट्रोल पंप सील होता है वही जानता है कि ये इंस्पेक्टर क्या होता है। नहीं,
जी 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 जी।
तब
So thank you very much sir, now we can start. अतुल
हाँ,
जी,
स्टार्ट कर।
Yes, sir. We are waiting, sir.
thank you very much. I would like, thank you. Very good morning to all. Today we have one another very important topic related with gas meters. As we are all aware, these PNG, pipe natural gas meters, are installed at most of the domestic places, commercial and industrial establishments. So the verification of these gas meters, testing of these gas meters is very important. Government of India has already framed the rules for gas meters, and we are also going to very soon, maybe within few days, we are going to start the verification of these gas meters with the help of private GATCs. There are many laboratories like FCRI, National Physical Laboratory, and other government establishments which have the facility of testing and calibration of these gas meters. Very soon, these facilities will also be available with other RRSLs, Regional Reference Standards Laboratories, and the ILM Ranchi. And the private laboratories which already have these facilities can be utilized for the verification of these gas meters. We have with us our professor, Dr. VK Pandey, Vivek Kumar Pandey ji. He is an assistant professor having BTech and MTech, more than 21 years of teaching experience in the weights and measures, electrical measurement instruments, circuit theory, electrical machines, etc. He has a lot of experience in the field of legal methodology, teaching the officers of the legal methodology, not only from India, but other countries at ILM Ranchi. Thank you very much, sir, for accepting our request and to deliver a talk on this very technical topic of gas meters. Thank you. Thank you. We have with us our Honorable Shri B.N. Dikshit, sir. Sir, I would like to request you to kindly speak 2 words before starting the program. Over to you, sir. Please.
थैंक यू। श्री आशुतोष अग्रवाल जी, डायरेक्टर लीगल मेट्रोलॉजी, गवर्नमेंट ऑफ इंडिया। So we are very thankful to him that every Saturday he is organizing nice program on the different topics. Sometimes it is technical, sometimes it is non-technical also, like mm, package county and related some type of items also. And we have with us our uh, dear Assistant Director, Dr. Vivek Pandey, who is the young scientist and having very good knowledge in various subjects of the legal methodology. The today topic is also being discussed by the Prime Minister that this gas meter should be installed in various places in the Varanasi, and the project is going on there. So even he is interested to have this gas meter at various cities and towns and different places to remove the problem of LPG cylinder and so many other type of things. So it is very important from the safety point of view also, and for the kitchen also, where the peoples are being benefited, and every time when they are interested for cooking, they can do the cooking. There is no need that there is need of the LPG gas cylinder to be refilled and call for the next cylinder and other type of things. It is the regular supply and continuous supply, only the bill has to be paid every month and all that very things. The gas meters provisions are part of the legal methodology. Rest is the part of the other department, installation and so many supply and all that very things. So it has been discussed from last 20 years, I think. Every time this issue has been discussed in the Department of Consumer Affairs. Now it is very good that the director has taken the initiative to verify the gas meter, and the verification it will be done through the both government sector as well as the private sector also. So this is very good idea what he is thinking, and it will be very much beneficial to the people. And from Ranchi, I hope that Dr. Pandey will initiate all the thing there, that how it should be tested and how it will be much influential to the people there, and he has to uh, assist always director legal methodology and organize the various program at different places. Even though this program is at the national level, Astoji, this is very good thing that this is going on national level. People are being from all the states, and they are participating in the programs. Most of the legal metrology officers who are knowing about that very thing, they participate in this very program for their knowledge and discussion and so many other type of things. Industry peoples are also participating to get their good knowledge. Scientists are also coming who are interested for to install new industry and other type of things. So the government has initiated many type of things. So people are starting their own factory and other type of things, leaving the job and all that very things. A startup, it is called startups. So you should promote the startup also from these very programs, because every program is having some manufacturing things. So a startup may play the very important role for the manufacturer and industry people. So I wish for the success of the program, and uh, thank you that you are organizing this very program. Hopeful that Dr. Pandey will give the nice lecture and will be benefited. All the people who are participating in the program will be benefited. Thank you, Astoji. Thank you, Pandey
Thank you,
Saab
sir.
and the participant.
Thank you, sir. Thank you very much for your kind and motivating words. We are always thankful to you. You are with us forever, always. Thank you, sir. Thank you very much. Thank you. Now, I would like to request Professor Pandey to kindly deliver his talk and enlighten us with his vast knowledge and experience. Over to you, sir. Please.
Thank you, sir. A very good morning to our respected Director Legal Metrology, Ashutosh Agrawal, sir, and our very respectful ex-director, Shri B.N. Dikshit, sir. He always use nice words for all the legal metrology officials as well as other officers. And today, I am very much thankful to Ashutosh sir who has given this opportunity to speak about this one of the very important measuring instrument which is recently included in our general rules. And I would like to congratulate Ashutosh sir for every week he is running this workshop for sharing the useful information in the various fields and areas by different speakers, and it is always in very useful for all. So I uh, give my heartiest congratulations to Ashutosh sir. And now, with his permission and B.N. Dikshit sir's permission, I'd like to start my presentation on this topic. So I'm going to share the slides.
Please, please.
Yes, so gas meters. Today, this topic, one of the measuring instrument used for the measurement of quantity of gas, which is being transferred for the domestic purpose as well as for the industrial applications. My presentation today will be
Yes, visible.
specifically based upon legal metrology general rule 2011, as well as I will speak little bit technical things about the functioning and working of these gas meters. So before I start discussing the technical things, yes, when we talk about these gas meter, which is recently included in our Legal Metrology General Rule 2011, in Part 11 of 8th schedule, which is meant for the measuring instrument basically, and it was notified by our Ministry of Consumer Affairs, Food and Public Distribution, Government of India, using the powers of subsection 1 and 2 of Section 52 Legal Metrology Act 2009. And it was notified on 21st of April 2025, and it came into force from this 1st September 2025 itself. And the objective of these general rules or the rules for the gas meter is to define the metrological characteristics for uh, gas meters like accuracy, repeatability, and stability, and other metrological characteristic parameters. It also defines the technical design and safety standards which is required for the operation or the functioning of the gas meter for the industrial purpose as well as domestic purpose. Then it also includes, means I'm talking about the rules. So it also includes the period of verification and re-verification of these gas meters so that we can ensure its accuracy, reliability, and obviously the public trust. Okay, so whether this instrument is being used in an accurate manner or not. And it also includes the testing and certification process. That means whenever a legal metrology official is going to verify a gas meter after a certain period, or it is going for re-verification, or it is suppose some gas meter is manufactured by a manufacturer, so whether it is means it is as per the requirement of our general rule or not, so it should be checked for its model. So what will be the model approval process? Okay, so all these things or all these aspects are included in our this rules. And yes, this rule for the gas meter is designed on the basis of our international standard for these gas meter, which is published by International Organization of Legal Metrology, and this recommendation is known as OIML R137. So we are basically harmonizing the our standards with the international standard. Now, when we talk about the scope of this rules for gas meters, which is included in our general rule, so these gas meters basically includes those gas meters which are used for the domestic purpose, as well as industrial, as well and commercial purposes. And it doesn't matter whether the quantity of gas is being measured in terms of volume or mass, and what type of technology is used, whether it is electronic, ultrasonic, turbine, diaphragm, or rotatory type, or any other technology. It will be covered under this scope, means the scope of these rules. But at the same time, those gas meters like compressed natural gas dispensers, CNG dispensers, this is not the part of these rules. This is not included in these rules, because there is a separate rule for these CNG dispensers already published in our Legal Metrology General Rule 2011. And suppose there is a liquefied gas meters, multi-phase type, or steam or vapor phase flow meters. So these gas meters are not the part of these rules which I am talking today. Uh, when we talk about the technologies, as I already mentioned, that there are various type of technologies used in the measurement of volume or the quantity of gas. So I'm going today going to speak a little bit about few technologies which are very commonly used nowadays in the measurement of quantity of gas. One of such technology is ultrasonic gas flow meters, a very useful one where the duct size or the pipe size is suppose big. So in bigger size funnel or the bigger diameter size pipe size, these ultrasonic gas flow meters work in a very accurate manner. So as you can see from this diagram, if we want to understand the basic principle of working, so you can see that in this block diagram, there is a funnel where the gas is being transferred from downside to upside. And there are two ultrasonic sensors connected with this funnel, one on upper side and one at lower side. So and these two ultrasonic sensors are basically controlled by ultrasonic controllers. You can see that they are both are connected with the ultrasonic controllers. This ultrasonic controller is basically controlling the operation of these ultrasonic sensors in a manner so that one ultrasonic sensor will act as a transmitter at a time, and another at the same time will act as a receiver. And whatever signal is received by both of these ultrasonic sensors, they are transmitted to the ultrasonic controllers, and based upon those signals and the informations, it gives the quantity or the information about the quantity of gas in terms of mass or volume. So if you can see in this picture, you can easily understand that suppose at a time, say ultrasonic sensor A is right now acting as a transmitter. So it is transmitting an ultrasonic sound wave which will reach to ultrasonic sensor B, which at the same time is acting as a receiver. So you can see that when ultrasonic sensor A is acting as a transmitter and the wave is transmitting from A to B, so this wave will reach to ultrasonic sensor B, which is right now receiver. So it will reach in a lesser time. Why? Because the gas is flowing in upside direction, which will support the movement of sound wave. So it will take lesser time to reach from A to B, and the moment it will reach to B, the information will be collected by ultrasonic sensor B and it will be supplied to the ultrasonic controllers. And now that ultrasonic controller will do what? After recording that information from ultrasonic sensor B, it will change the operation. That means ultrasonic sensor B will now start acting as a transmitter and ultrasonic A will become receiver. And in this situation, when ultrasonic wave will transfer from B to A, it will take more time to reach to ultrasonic sensor A. And if it is taking more time, so there is a time gap between both of these operations. Then means when the wave is transmitting from A to B and when wave is transmitting from B to A, there is a time gap. Now this time gap is what? It is directly proportional to the flow rate of the gas. So more the flow rate of the gas is there through the funnel, more time gap will be there in both of these operations. And this is basically calibrated, or you can say calculated in terms of quantity of gas. So this is the basic operation. I'm not discussing in detail about the operation, but this is the basic operation of this ultrasonic gas flow sensors, gas flow meters. Now, another technology which is very commonly used is the turbine gas flow meters, where you can see that in this diagram that inside the gas meter there is a inductive coil, and there is a impeller, and in that impeller, which is rotating with the help of rotating shaft, within that impeller you can find a small magnetic pole. So what is happening whenever the gas is passing through this pipeline? So that gas, the direction of gas is it should be straight. So to make it straight, straightening vanes are there, which is providing the straight direction or straight for straightward direction to the gas flow. And with the gas pressure, what will happen, that rotor will start rotating, and when this rotor will rotate, the magnetic pole will also rotate. And we know very well, then when magnetic pole is rotating, it means what? Indirectly the magnetic field is rotating, and this magnetic field will interact with the inductive coil connected nearby that rotor, and that inductive coil will then produce what? A small voltage, or you can say the voltage pulse. Now these voltage pulses are directly proportional to what? The quantity of gas passing through the this rotor or the turbine. And yes, these voltage pulses will be then processed, and it gives the information about the quantity of gas passing through this gas meter. So this is another technology which is very commonly used in the gas measurement. This is the third type of technology used in the gas meter. This is positive displacement meters. In these positive displacement meter, you can see that there are two oval shaped gears are there, and whenever the gas is passing through these oval shaped gears, so at a certain position of these gears, a small chamber is created inside the measuring system, and that small chamber is what? It is well calibrated. That means the quantity of gas is fixed for that chamber. So if I'm saying that the quantity of gas for that small cavity created between the two gears is say 100 ml. So the same 100 ml cavity will be created in a different position on upper side for a different position of the oval shaped gears. So in one complete rotation of these oval shaped gears, because of the gas flow, obviously when the gas is flowing through the meters, obviously they will apply the pressure on these gears and the gears will rotate, and due to change in the position of these gears, a certain quantity of the gas will be trapped inside the cavity, and then it will pass through the outlet part of this gas meter. So within a certain in one complete rotation, a certain amount of gas will be transmitted. So this is another technology which is being used for the measurement of quantity of gas. This is another rotary piston type gas meters. This is a kind of technology which is used in the gas meter, and as there are mechanical type of, or you can say the metallic components are there inside this meter. So these types of gas meters are what? They are very, very reliable. You can say they are more durable. Okay, so based upon the functioning of these gas meters as well as the technology which is used inside the gas meters, in our general rule, the verification periods are defined. So if you will carefully observe this particular table, where I have not taken all, but I have taken few of them. So you can see that in this table, the period of verification and re-verification is mentioned for these gas meters. That means after how much time the gas meter should be recalibrated and re-verified. So you can see that in rotary piston type meter, technology, the initial verification period is 20 years and the subsequent verification period is 17 years. It is more than you can say other technologies which is used in the gas meter. Why? Because in the rotary piston type meters, what is there? There are metallic components are there. So there is very less wear and tear effect due to operation of these meters. So they are more durable. But in other technologies, like if I'm talking about diaphragm type gas meters, so what is there that these diaphragm type gas meters are mostly used for the domestic purpose. And there in that diaphragm type gas meters, due to wear and tear, its component needs replacement, okay, frequent replacement. So that's why the verification period is what? It is less comparatively as compared to rotary piston type meters. Similarly, turbine type gas meters are basically used in those industrial application where huge flow of gas quantity is there. I mean, the quantity of gas is more during the transaction. Okay, so these gas meters also needs frequent verification, because more the quantity of gas passing through the meter, its reliability will reduce. Similarly, there are other meters also. If I'm talking about, suppose, ultrasonic gas meters, so there are electronic sensors. As you have just seen in the diagram, that ultrasonic sensors are there. So their functioning degrades after a certain use or after a certain period of use. So that's why these ultrasonic gas meters also needs frequent recalibration or re-verifications. Now, let us come to the some important terminologies which is mentioned in this gas meter regulations in our Legal Metrology General Rule 2011. I am covering only the important one. Like the first terminology is measuring transducer. Now, we all know that transducer is what? It is one kind of electrical as well as electronic component which converts a mechanical signal into an electrical signal, or you can say mechanical rotation is converted into an electrical signal. Fine. So this is a convergent device. Now, once this signal is converted, or the energy is converted from one form to other form, suppose it is converted in electrical form, and electrical pulses, voltage pulses is generated because of the motion of measuring component inside the gas meter. So these pulses must be recorded and calculated by certain segment of the gas measuring unit, and that particular task is done by the calculator. So calculator basically calculates the pulses or electrical signals received from the transducer, and then it process it so that the quantity of gas may be indicated in indicating as well as or displaying devices. Now, when we are talking about indicating or displaying device in context with our gas meter regulation, so a printing device is not covered as an indicating device in the regulation of gas meter. Now, in all modern gas meters, we find some correction device which is used for the correction with respect to the known errors. So suppose if I'm talking about that there is a inside a gas meter, there is a temperature correction device. So temperature correction device means what? That instrument is meant to measure the quantity of gas at a certain specified temperature. Now, suppose the temperature of that gas which is passing through the measuring unit is changing, or it is varying. So with respect to variation in that temperature, how the measurement result will be corrected, that will be done, or that will be performed by certain correction device. Now that correction device is the part of the measuring system, okay, and that correction device might be correcting the errors for temperature as well as pressure, for humidity, or specific density or relative density of the quantity of relative density of the kind of gas which is passing through the measuring unit, because we know very well that is specific density or relative density is changing, so definitely it will impact the measurement result. If the pressure is changing, obviously it will impact the measurement result. So for all these parameters, there must be a correction device available with the measuring unit. Now, the next terminology is the ancillary device, and this is nothing but what it is a kind of components available with the measuring unit, like repeat indicating device, printing device, memory device, or communication device. Means after measurement, so suppose measurement has already happened, and the primary display or the primary indication unit is already displaying the result. Now you want to process the same measurement result to for other purposes, like you want to take a printout, you want to store the data, you want to indicate the result in some alternate display. So for all these purposes, whatever devices are attached in the gas meter, they are called ancillary devices. Next one is the associated measuring instrument. Now this associated measuring instrument is what when we are talking about the gas meter is specifically meant for the measurement of quantity of gas, but at the same time, as I told you, that we need some correction devices, so that if there is any variation in the temperature, accordingly the correction in the measurement can be applied inside the measuring unit. So how that correction will happen? Until and unless we should be having a temperature sensing device inside the gas meter, which can detect the you can say the time, the temperature of the gas at during the certain transaction. Okay, so currently what is the temperature? So to measure that temperature, there should be a temperature measuring device. To measure the pressure of the gas, there should be a manometer, calibrated manometer, which can measure the pressure of the gas, so that if there is any variation of the pressure with the specified pressure level or the desired pressure level, so accordingly the correction can be made. So to measure all these parameters which are directly or indirectly associated with the measurement result, we need associated measuring device. So all these manometers, temperature measurement system, humidity measurement system, specific density measurement system, these all are what? Associated measuring instrument. Now, in the next part of this presentation, I'll be discussing about the operating conditions for the gas meters in context with our regulation. When we talk about the operating conditions, so the most important parameters are what? The flow rates, because these are the these flow rates are what? The parameters which is directly associated with the measurement result, or you can say the accuracy of the gas meters. So in context with our regulation, there are three important flow rates specified in our rule: the maximum flow rate, the minimum flow rate, and the transitional flow rate. Now, when we are talking about the maximum and minimum flow rate, so it is a specified range of the flow rates specified by the manufacturer, and obviously the certified by the regulatory authority, that within this flow range, if the gas meter is operating, so it will give you the desired level of accuracy. That means any error observed during the operation of the gas meter, and if the gas meter is operating within the minimum to maximum flow rate, so it will give you the error within the maximum prescribed tolerance. Fine. So now this within this minimum to maximum flow rate, there is one more flow rate specified in our rule, that is transitional flow rate. And this transitional flow rate, from the name it is clear that it is a point within minimum to maximum flow rate where certain transition is happening or certain change is happening. Okay, and that transition is what? The transition of accuracy. Fine. So it means, if I'm saying that for a particular gas flow gas meter, within the minimum and maximum flow rate, there is a prescribed tolerance in terms of its accuracy. Fine. So that tolerance is basically different up to a level of transitional flow rate, and above that transitional flow rate, that tolerance level will be different, or it will be, you can say, changed. I mean to say, suppose if I'm taking the example of any particular gas meter where the tolerance is, say, 0.5% or 1%. Fine. So from minimum flow rate to transitional flow rate, the tolerance will be something else like 1%, and from transitional flow rate to maximum flow rate, the tolerance of the gas flow meter with respect to its accuracy will be different, like 0.5%. Okay, so this tolerance is changing means what? Its accuracy is changing. Fine. So this tolerance, this transitional flow rate is also an important flow rate which is specified by the manufacturer. Now, when we talk about further in respect to this operating condition, so there is a working temperature. That means when the gas meter is being operated for the measurement of gas during a particular transaction, so what is currently the temperature of that gas? So it is being measured by a temperature sensing device, and whatever indication it is giving, that is working temperature. And yes, there is a specified temperature range for all the gas meters by the manufacturer, that it will act accurately within a certified temperature range like T minimum to T maximum. So suppose if I'm saying that for a particular gas meter, the specified temperature range is -10 degrees Celsius to 40 degrees Celsius. So it means manufacturer is giving the assurance that if it is being operated within -10 degrees Celsius to 40 degrees Celsius, so its accuracy will remain intact. Similarly, there is a specified temperature at which basically you can say this specified temperature is what? It is a parameter specified by the manufacturer for the temperature correction device. So whenever a gas meter is being used for the measurement of quantity of gas, suppose the temperature of the gas is deviated from the specified temperature value, so how much correction should be made? For that, there is a fixed specified temperature given by the manufacturer. Okay, so that specified temperature is prescribed by the manufacturer, and accordingly the temperature correction will be done. Now there is a working pressure also specified, working pressure which should be measured when the gas meter is being operated with the help of a calibrated manometer. That means the current temperature of the current pressure of the gas. Then there is a pressure range which is specified by the manufacturer, that within minimum to maximum pressure range, what is the minimum to maximum pressure range within which the accuracy of the gas meter will be intact. So that is also specified. Then there is a static pressure loss or differential pressure. This is also a very important parameter in gas meter functioning. Why? Because if there is a pressure loss more than the specified pressure loss by the manufacturer in the certain gas meter, so definitely there are the chances of lesser accuracy, or you can say the error observed will go more, or it will be more. That means suppose a gas is passing through the gas meter, so there is a manometer connected on inlet side and there is a manometer connected on outlet side. So what is the difference in pressure because of those gas meter, because of the gas meter? What is the drop in the pressure in the gas supplied through the gas meter? So that drop in the pressure should not go beyond certain limit, because if it is going beyond certain limit, it means your measuring instrument is not acting or working satisfactorily. Okay, there are the chances of errors. Now the other parameter is working density, that what is the density of the gas which is passing through the gas meter at a certain time. So that density should also be measured by a density measuring device. Now the next particular section which I will be discussing in the gas meter is the metrological characteristic. In metrological characteristic, the first parameter which I am going to discuss is the weighted mean error, a very important parameter which ensures the accuracy of the gas meter. And this weighted mean error is what? Basically, this is just like we try to find out the measurement error in case of any measuring instrument. So usually what we do whenever we are trying to calculate the error in the measurement by any measuring instrument, we compare the indicated value with some reference quantity and we get the percentage of error. Fine. So that is called basically the accuracy check, or you can say the accuracy error in the accuracy of the measuring instrument. That error we will also try to find out during the verification of these gas meter. But apart from that accuracy error, which is basically calculated at different flow rates. So suppose we are performing the accuracy test on a gas meter, so it should be performed at a minimum flow rate, maximum flow rate, transitional flow rate, and at other flow rates specified with or decided between minimum to maximum flow rates. So error can be obtained or error can be observed for a gas meter at a certain flow rate. However, this weighted mean error is a very interesting parameter which gives you the accuracy of the instrument, measuring instrument, which is gas meter in this case, with respect to all the flow rates specified between minimum to maximum flow rates. That means between minimum to maximum flow rates, whatever flow rates we are selecting, what is the average error, you can say, or you can say the effective error. So that is called weighted mean error, which is basically calculated with respect to all the flow rates decided for the accuracy test. So if we have decided, suppose 5 flow rates to check the accuracy of a gas meter, so accuracy test for those 5 flow rates will be performed separately, and there will be a combined result in terms of weighted mean error for all these flow rate in terms of weighted mean error. So this is another very useful parameter, and this weighted mean error basically we calculate in case of gas meters during initial verification and pattern approval, or you can say model approval. Fine. Now there is a table you can see in case of this metrological requirement parameter, where in this table you can see that the various values or you can say rated parameters for temperature, relative humidity, atmospheric pressure, vibrational loss, DC supply, AC voltage supply, AC frequency, flow rate range, types of gases and working pressures are specified. So basically this table is prescribed in our rule just to ensure that whenever the manufacturer is manufacturing a particular gas meter, so they must ensure these parameters. As per this table, they should ensure the parameters for the gas meters. Like if he is suppose deciding the temperature range, okay, so temperature range must be selected between the values which is specified here in the table. Like the lower temperature can be prescribed as minus 40 degrees Celsius, minus 25 degrees Celsius, minus 10 degrees Celsius, 0 degrees Celsius, and 5 degrees Celsius. And higher range of the temperature can be selected between these values: 30 degrees Celsius, 40 degrees Celsius, 55 degrees Celsius, 65 degrees Celsius, and 70 degrees Celsius. Now there is one thing that whenever suppose he is or a particular manufacturer is specifying a temperature range, I just gave you in the previous slide about the detail about that temperature range, minimum temperature range to maximum temperature range. So whenever a manufacturer will select the temperature range, he cannot select like suppose if I'm taking from the table like a particular range minus 10 degrees Celsius to 30 degrees Celsius. Okay, so minus 10 degrees Celsius is the lower temperature, suppose a manufacturer is deciding, and maximum temperature is deciding as 30 degrees Celsius. No, it is not allowed, because our rule is saying that minimum 50 degrees Celsius gap should be there. So if he is deciding lower temperature as minus 10 degrees Celsius, he can go for 40 degrees Celsius, 55 degrees Celsius, 65 degrees Celsius, or 70 degrees Celsius. He cannot choose higher temperature as 30 degrees Celsius. Fine. So these are also defined in our regulations. Similarly, there are other parameters, like if I'm talking about, say, voltage supply. So AC voltage supply, the nominal supply, if suppose it is 240 volts, normally we are getting single phase supply 240 volt, nearby 240 volt. So plus minus 15 degrees Celsius variation might be there, or lower temperature, lower voltage range will be there, and upper voltage level should be 240 volt plus 10 degrees Celsius. Okay, so it is nearby 244 volts, you can see. So this is one thing. Then similarly, if I'm talking about the frequency supply, So usually in India, we are following the standard for 50 hertz AC supply frequency. So here the variation is specified that the gas meters, in case of gas meters, suppose some electrical supply is connected with the gas meter and it is AC supply. So frequency may vary plus minus 2%. Like, so if I'm saying 50 hertz, so 1 hertz frequency might vary. So frequency can vary between 49 hertz to 51 hertz. So accordingly, the parameters should be specified by the manufacturer, and it must be assured also, because these all parameters will directly or indirectly impact the operation or the accuracy of the gas meters. Now in the metrological requirement, the next parameter is this. You can see a table is specified, and I just spoke about the 3 flow rates: maximum flow rate, minimum flow rate, and transitional flow rates. And here I have taken a particular example of a gas meter where the maximum, minimum, transitional, and overload flow rates are specified. So you can see that how you will check whether the specified flow rates by the manufacturers are correctly given, because a manufacturer also cannot define, cannot give any value for the maximum flow rate, minimum flow rate, and transitional flow rate, because I told you that between minimum to maximum flow rate, the transitional flow rate is a point where the accuracy is changing. So whether that particular point is correctly selected or not, so that is already specified in our rule. So you can see here that if in our example, you can see that the maximum flow rate specified by a manufacturer is 2500 liter per hour. Minimum flow rate which is specified is 100 liter per hour. Transitional flow rate is 500 liter per hour. So whether these 3 flow rates are correct or not, suppose we want to check it. So in our rule, a table is specified for checking this detail, and you can see that the ratio of Q maximum to Q minimum, if it is greater than or equal to 50, then ratio of maximum flow rate to transitional flow rate should also be greater than or equal to 10. If this condition is followed, then it is correct. Otherwise, suppose Q maximum to Q minimum ratio is not more than or equal to 50. Suppose it is more than 5 and less than 50. So it is between 5 to 50. So in that case, Q maximum to Q transitional ratio should be greater than or equal to 5. So in our case, you can see that the maximum to minimum flow rate ratio, 2500 divided by 100, it is what? It is 25. So it is 25 means what? It is not more than 50. So it is lying between 5 to 50. So second row of this table will be or can be considered here. So Q max to Q minimum ratio is 25 here. And the second row is saying that Q max to Q minimum may vary 5 to 50. So it is satisfying that. But let us see whether Q max to QT is also satisfying this condition or not. So according to the second row, Q max to QT should be greater than or equal to 5. And in our case, it is what? It is 5. Because QT is 500 liter per hour and Q minimum is 100 liter. Sorry, Q maximum is 2500 liter per hour and Q transitional is what? 500 liter per hour. So if you will divide the Q max with QT, you will get what? 5. Fine. So it means what? Both of these ratios are what? Complying with the condition. That means these flow rates specified by the manufacturers are what? It is what? It is correct as per our regulation. In this same example, you can see another flow rate specified here, that is called overload flow rate. About this flow rate, I'll be talking in detail in the upcoming slides. But here, one thing you should be knowing, that this overload flow rate is also specified by the manufacturer, and this should be what? It should be 1.2 times of Q max. Okay, 1.2 times of Q max. So 1.2 times of Q max, in this case, you can see if it is 1.2 times of Q max means 1.2 times of 2500. So it is what? 3000 liter per hour. So it is correct. Fine. So overload flow rate is also correctly specified here. Now, what is the purpose of this flow rate, that we will discuss later on. Now, when we talk about in this metrological requirement section, there are 3 accuracy classes specified for the gas meters: 0.5, 1 and 1.5. 0.5. So these are the three accuracy classes specified for different gas meters. Now, whether they are ultrasonic, whether they are diaphragm type, whether they are positive displacement type, that doesn't matter. Okay, any technology can be used in all these three accuracy classes. And based upon these accuracy classes, basically the accuracy levels are specified, means what is the prescribed tolerance. So later on I will show you that also. So you can see in this table, in this table you can see that where what is given, it is specifying the maximum permissible error for the gas meters. And this maximum permissible error table is basically divided in two segments. One is for model approval and initial verification part, and another one is for re-verification and in-service inspection. So obviously when we are talking about model approval, so it is being done by regional reference standard laboratories here in our country. They are giving the model approvals for different weighing measuring instruments, or you can say weights and measures. And based upon the accuracy classes of the gas meters, whenever suppose a gas meter is being checked during model approval and initial verification, initial means first verification, fine. So the tolerance level is what you can see, that if a gas meter is of accuracy class 0.5, so during model approval its maximum permissible error can be plus minus 1% when the gas meter is tested between minimum flow rate to transitional flow rate. And the same gas meter of accuracy class 0.5, if it is being tested from transitional flow rate to maximum flow rate, then the maximum permissible error is specified as plus minus 0.5%. So you can see here the thing I was trying to explain you, that transitional flow rate is a point where what the MP is changing, the accuracy of the instrument is changing, fine. And in this also one thing is to be noted, that transitional flow rate is included in what, in the next accuracy, that means next MP, that means plus minus 0.5% tolerance is specified for the gas meter which is tested exactly at QT. So if you are testing a gas meter exactly at transitional flow rate, so MP will be plus minus 0.5%, but just below QT the MP will change, it will become plus minus 1%. Okay, similarly it is specified for other accuracy classes, fine. And you can observe one more thing, that MP, or you can say this tolerance is double in case of re-verification and in-service inspection. So same gas meter, if I'm talking about 0.5 accuracy class gas meter, so between Q minimum to Q transitional, the tolerance will become plus minus 2%, means double of the in-service inspection, initial verification and model approval. Okay, so during re-verification and in-service inspection, the tolerance will get double. So plus minus 2% between Q minimum to QT, and plus minus 1% for accuracy class 0.5. Now here one more thing is to be considered, and that is what? That is the variation of these MPs based upon the temperature of the gas. Because unlike other measuring instruments specified in our rule, here in case of gas meters, if the gas temperature is varying, it can change the quantity of gas, or you can say measurement result, considerably based upon variation in temperature. So depending upon that, the tolerance level is also changed. You can see here that for the tolerances specified in the table, another statement is given just below the table, that suppose a specified temperature for a gas meter by a manufacturer is say 30 degrees Celsius. Okay, he has specified that the specified temperature is 30 degrees Celsius for a gas meter. So 30 degrees Celsius, if it is 30 degrees Celsius is the specified temperature, so in respect to our this MP table, T specified minus 15 degrees Celsius to T specified plus 15 degrees Celsius, okay, if temperature is changing, means suppose your gas is being transferred to the gas meter and the temperature is not 30 degrees Celsius. It is more than 30 degrees Celsius or less than 30 degrees Celsius. So obviously what? It will affect the measurement result. So suppose the temperature is 25 degrees Celsius. So it will change the volume or it will change the quantity. So accordingly, the correction should be made, fine, by the correction device. But during the testing process, when we will check when we will check the accuracy of the gas meter, so tolerances which we will consider for its accuracy of the gas meter, that should also be changed. Like the same example, the specified temperature is suppose 30 degrees Celsius, but currently the temperature of the gas is 25 degrees Celsius, fine. So it means what? It is falling in the range which is given in this table. That means 15 degrees Celsius to 45 degrees Celsius. T is specified minus 15 to T is specified plus 15. So what is the range? If the specified temperature is 30 degrees Celsius, it is 15 degrees Celsius to 45 degrees Celsius. So currently, if the temperature is 25 degrees Celsius, it means what? It is falling in this range. So it is saying that if the temperature is not equal to specified temperature, but it is lying in this range which is given here, fine. So the MP will become what? 0.5% more than the specified MPs for the gas meter depending upon its accuracy class. For example, if I'm taking accuracy class as 0.5 and Q minimum to Q transitional for flow rate of Q minimum to Q transitional, suppose MP is plus minus 1%. So for this specified temperature range, the MP will become what? 1.5%, 0.5% more. And what? Suppose your working temperature of the gas is what? It is going beyond this range. T specified minus 15 to T specified 15 plus 15 degrees Celsius. Suppose it is going beyond this range. So if it is going beyond this range, then for that also it is mentioned that the tolerance level will change by further 0.5 degrees Celsius, 0.5% for each 10 degrees Celsius increase. For example, specified temperature is 30 degrees Celsius, working temperature is 25 degrees Celsius. So MP will increase only by 0.5%. But suppose your specified temperature is 30 degrees Celsius. So according to this, the range should be what? 15 degrees Celsius to 45 degrees Celsius. But suppose gas temperature or the working temperature is suppose 10 degrees Celsius. So it is what? It is beyond this range. So if it is going beyond this range and if it is within 10 degrees Celsius extra gap, so 1% MP will be further means 0.5% MP will be further adjusted or it will be considered. So this is about the MP or the tolerance during the accuracy test. Now this is the table specified for the weighted mean error. I just spoke about this parameter, that in case of weighted mean error, I told you that this is a very important parameter basically. Why? Because it can tell you directly that whether a gas meter is working fine for all the flow rates specified or not within minimum to maximum flow rate, because it is a weighted quantity. It is the effective quantity for all the flow rates, fine. So and this particular parameter is mostly used for a gas meter during pattern approval, sorry, model approval and initial verification, fine. So you can see that for re-verification and inspection there is no value specified for weighted mean error because it is not required. And in model approval and initial verification for 0.5 accuracy class, weighted mean error should be plus minus 0.2%. For accuracy class 1, it is plus minus 0.4%. For accuracy class 1.5, it is 0.6%, plus minus 0.6%. Now, later on, I'll be speaking about the test which is performed on the gas meter during model approval and initial verification as well as re-verifications. I'll be discussing about these two parameters, reproducibility and repeatability. Now, these two parameters are also very important with respect to the accurate functioning of this measuring instrument, where what is repeatability? So this repeatability in context with the gas meter is what is the consistency, how much consistent your gas meter is in respect to the measurement of quantity of gas. That means if suppose a gas meter is there and the specified flow rate by the manufacturer is say 100 liter per hour to 500 liter per hour. This is the range of the flow rate. Minimum to maximum flow rate is specified by the manufacturer. Now suppose that gas meter is being checked for its consistency, and we have decided that I will check its consistency at a fixed flow rate of 200 liter per hour. So within 100 liter per hour to 500 liter per hour, I have decided a particular flow rate 200 liter per hour to check its consistency, whether at 200 liter per hour flow rate its result is consistent enough or not. Okay, so how we will check it? At 200 liter per hour flow rate, we will make transaction through that gas meter one time, then second time, then third time, then fourth time, then five time. We will take multiple readings. Okay, so suppose we have taken 5 readings to check its consistency, but whenever we are making these 5 readings or 5 indications in respect to the gas meter for consistency check, we should ensure that first we should remain consistent. That means the user should be same, the environmental parameters should be same. That means there shouldn't be any change in the density of the gas, there shouldn't be any change in the temperature of the environment or the laboratory, there shouldn't be any change in the humidity, there shouldn't be any considerable change in the pressure of the gas. Fine. And yes, the most important thing, the flow rate of the gas should be same. That means if we have decided that we will check the consistency at 200 liter per hour, so it should be 200 liter per hour for all the readings. Fine. And after taking these readings, suppose 5 readings we have taken, so we will compare the error. Okay, that means at 200 liter per hour flow rate, what is the error in the indication in the first result? Then what is the error in the indication in the second result? What is the error in the indication in the third result? So similarly, we will get how many errors? 5 errors in the accuracy at same flow rate. Now within these 5 readings, what is the maximum error, what is the minimum error, and that difference should be what? It should be less than or equal to 1/3 of the maximum permissible error specified for that gas meter in the MP table. So I have just shown you a tolerance table, a maximum permissible error table, where the MP for different accuracy classes and different flow rates are specified. So suppose for a particular flow rate and accuracy class, the MP is say 2%. Fine. So in repeatability test, maximum to minimum variation in the error, the difference in maximum to minimum error should be what? It should not be more than 1/3 of 2%. Okay, so 1/3 of the MP is specified. Similarly, when we are doing suppose reproducibility test, now this reproducibility test is what? It is little bit same as repeatability, but there is one difference, that whenever we are performing reproducibility test, the flow rate might change. We can change the flow rate. So if suppose I am taking the same example of the gas flow meter where the minimum flow rate is 100 liter per hour, maximum flow rate is 500 liter per hour. So suppose we are taking first reading at 100 liter per hour, and the second reading we are taking at 200 liter per hour. The third reading we are taking at 400 liter per hour. Okay. But if we are transferring the same quantity of gas during all these transactions or during all these tests, fine. So at 100 liter per hour, we have made a transaction of 1000 liter of gas. Okay. Then at 200 liter per hour, we have made the transaction of 1000 liter of the gas. So quantity is same, but it is being transferred through the same gas meter at different flow rates without changing the environmental parameter, I must say. That means rated operating condition must be same. So at all these different flow rates, same quantity of the gas is transferred with the same gas meter. Okay. So what is now the variation in its accuracy? What is the variation in the error observed in the different indication? So that variation means maximum error to minimum error difference for the different indications should again not go beyond 1/3 of MP specified for that gas meter. So again, if the specified MP is say 1%, so for reproducibility, the reproducibility error should not go 1/3 of 1%. Fine, beyond one third of 1%. Now, next metrological requirement, important one, which I'm discussing is called durability of the gas meter. This is a test which we perform on the gas meter during model approval as well as initial verifications. Fine. So what we do basically during this test, we we try to check the reliability of our instrument. Means how much durable it is, how many years we can use it without its accuracy being affected. So what we do it in case of durability test, we run our gas meter between a flow rate of 0.8 times of Q maximum to Q maximum. We can decide any flow rate. We can also run it at Q maximum flow rate. Fine. So suppose a gas meter is there and its maximum flow rate is specified as 1000 liter per hour. So during durability test, we can make the transaction of gas at between 800 liter per hour to 1000 liter per hour flow rate, and for how many duration? For 2000 hours continuously. So for 2000 hours we will run that gas meter continuously, and after running it for 2000 hours, then again we will perform what? Its accuracy test. And during that accuracy test, if it is giving the same accuracy, that means an accuracy, you can say the error is within the prescribed limit of the tolerance in our rule. So what we can say that it is durable, or it is passed in the durability test. Next, overload flow. Few slides back I have shown you a particular example where maximum flow rate for a gas meter was specified at 2500 liter per hour, and overload flow rate was specified by the manufacturer as 3000 liter per hour. So I told you that that overload flow rate is specified by the manufacturer should be what? It should be 1.2 times of Q maximum. So here you can see that the sentence is given and that manufacturer has specified it correctly. So 3000 liter per hour is what? It is overload flow rate, and it is being used. That flow rate is basically used in the overload flow test. And in that test, what we do? We run our gas meter at a higher flow rate, or you can say more than the Q maximum flow rate. And more than Q maximum flow rate means what? We will run it at overload flow rate. Fine. And in this case, suppose maximum flow rate is 2500 liter per hour and overload flow rate is 3000 liter per hour. So we will run at a rate of 3000 liter per hour for 1 hour. Continuously 1 hour we will, means you can say we are making a gas meter over stressed. Okay. So at a heavy flow rate, the gas will pass through the gas meter for 1 hour, and after running it for 1 hour, we will again check its accuracy at a flow rate between minimum to maximum flow rate. And if it is giving the error within the tolerance, that it means what? It has passed the overload flow test. Now, when we talk about the technical requirements as per our gas meter regulation is specified in our rule, general rule in part 11 of Legal Metrology General Rule 2011. So these are the technical requirements which a gas meter should fulfill. The first point is what? Environmental resistance. Now this environmental resistance means what? A gas meter should be resistance to the temperature variation, means generally it should be between minus 40 degrees Celsius to 70 degrees Celsius. So if the temperature is ranging between minus 40 degrees Celsius to 70 degrees Celsius, we should check whether our gas meter is resistance for these variations or not, temperature variations. Okay. So in environmental resistance, we check for temperature variations. Then we check for the humidity variation, that whether it can sustain in terms of its accuracy and functioning at a humidity or up to a humidity level of 93% or not. Okay. Then we should also check it for the vibrational effect. Okay. So if there is any vibrations between 10 hertz to 150 hertz. Okay. an acceleration of 7 meter per second square. So whether it can withstand with that vibrational level or not. So this is another environmental resistance requirement, technical requirement for the gas meter. Then there is a electrostatic discharge requirement. So we in case of a gas meter, when suppose the gas meter is made of certain metals, okay, so we try to apply electrical you can say shock. We give an electrical shock ranging between 6 kilovolt to 8 kilovolt to those gas meter to check this electrical discharge level, whether it can sustain with that electrical impact or not. Fine. So this is another technical requirement. Then another important technical requirement is related with the electromagnetic interference. Another very important parameter, because if there is the electromagnetic radiation within the industry surrounding the application of the gas meter, so it can impact its operation as well as its accuracy. So electromagnetic impact, whether in the sufficient electromagnetic shielding is provided with the gas meter or not during manufacturing. So this should also be tested. So we apply an electromagnetic test on the gas meter, okay, and to check its compatibility for these radiations. Next technical requirement is related with the electronic meter requirement. So suppose the electronic type meters are there. So what requirements it should fulfill? So first requirement related to electronic meter requirement is what? It is related with the power failure. Okay. So suppose there is a sudden power failure in the industry during the operation of the gas meter. So during power failure, whether the gas meter is able to store the last data, okay, and it is able to display the last reading or not. So this should be tested. It is not like that sudden failure is happened and the previous data is vanished. No. So it should be tested in electronic meter requirement. Then the next requirement is related to the voltage dip, surges, and electromagnetic interference. I have just discussed to you in the previous case. The third one is electronic component must be sealed and tamper proof. All the electronic components must be properly sealed and they must be tamper proof. Okay, this is another technical requirement. Then it should have a calibration memory, so that and the calibrated memory should be of such type so that it should be protected from unauthorized changes. Okay, so there should be a calibration memory there inside the measuring instrument. Next technical requirement is related with the mechanical and safety requirements, where the meter body must withstand with 1.5 times the maximum working pressure. Okay, so if the specified pressure range is there for a gas meter, so more than maximum pressure if it is applied on the gas meter, 1.5 times more than the maximum pressure. Okay, so whether the gas meter is able to withstand with that impact or that mechanical surge or not. Then we will also check whether the gas meter is gas tight and it is water resistance or not. Then we will also check it for anti-tamper seal, and it should be having visible verification marks. Then in mechanical and safety requirement, another very important requirement is related with the safety, because in most of the cases this gas meters which are used in the industries, they can become dangerous in certain cases, certain accidental cases. Okay, so it should automatically stop gas flow during fire or seismic activity. So suppose there is an earthquake or there is a sudden fire problem is there inside the industry. So automatically there should be a device inside the gas meter which should stop the gas flow. Okay, so that so there shouldn't be any hazard to the people working there. Next, related to the display and indication unit, the clear, stable, and non-resettable display should be there. Then indication of the gas should be displayed, should display the quantity of gas in SI units. That means cubic meters or kilogram. So cubic meter means it can be cubic decimeter, it can be cubic centimeter. So cubic centimeter means milliliter, cubic decimeter means liters, okay, and cubic meters means 1 kiloliter. Fine. So kiloliter. So it can indicate the reading in kiloliters, cubic meters, kilogram. Okay. So such type of display should be there. And electronic display must retain last reading after the power interruption. Sudden power failure is there, so last reading should be there. Then when we talk about the construction and quality in case of technical requirement, so the corrosion resistance materials such as stainless steel or composite polymer should be used. No part of the meter should be easily removable without breaking the seal. There should be arrangement for this, that without breaking the seal, there shouldn't be any part which can be easily removed from the gas meter. Fine. Then manufacturer must register component numbers for its traceability. So a particular identification number of the meter should be printed there. Now, the model approval segment, we know very well that every gas meter, as per the our gas meter regulation, its model must be approved by the Director Legal Metrology before sale or its use. Okay, and during model approval, what evaluations is performed in case of gas meter? Basically, it is confirmed for its design, that is drawing and specification. It is also confirmed for the accuracy test, stability test, mechanical strength test. Then it is also tested for pressure, temperature, and environment. Then
All
it is also
participants are
tested.
requested to kindly switch off your mic. All participants are requested to kindly switch off your mic. Thank you. Even you can switch on your video, but kindly switch off your mic, please. Thank you. Over to you, sir, please.
Then it is also tested during model approval for electromagnetic compatibility test. Okay, and once gas meter is tested for all these segments, then a model approval certificate is issued by the Director Legal Metrology. Then when we talk about the initial verification, so before the gas meter is put into use, means model approval is done, but before it is going to be used for the transaction purpose, so it must be tested again. So this is called initial verification, and these tests are basically performed by the state legal metrology officers or government approved test centers. And normally these tests include the visual inspection. That means the marking, seal, serial numbers. These must be checked. Then it should be checked for pressure or leak test. We should check whether there is any leakages there or not, or it can sustain with the specified pressure of the gas or not. Then we will also perform the flow rate test and accuracy test. Then we will check for the repeatability test. As I already mentioned, that it is the check of the consistency of the gas meter, whether it is consistent or not. Then we also perform the electromagnetic test, then safety device test. After these tests are performed and the instrument is found satisfactorily, then a verification seal is applied to the measuring instrument, and it is being issued with the certificate. After a gas meter is initially verified and now it is put into the use, then as already I have shown you a particular table where the re-verification period, where re-verification period for different types of gas meters are mentioned. So according to that particular time interval, the gas meters must be re-verified or re-inspected. Okay, and during re-verification, mostly the legal metrology officers inspect its external condition of the meter. That means they check it for corrosion, leakage, dents, or damage. Then they also check whether the manufacturer markings are there or not. I will show you what marking should be there on the gas meter. Then they should also ensure that the verification seal or the lead and plastic hologram seals are intact. Okay, then during re-verification, they should confirm that there should be no unauthorized alteration or tampering with the measuring component of the gas meters. Then after, when they are satisfied with all these preliminary tests, then they perform actually the accuracy test on the gas meter at different flow rates. And once they are satisfied with its accuracy and functioning, they and suppose at certain flow rate the error is going beyond the limit, then they always means recommend it for adjustment and repair. And once it is adjusted and repaired, then it is again verified and resealed. These are the important markings which should be available with the gas meters. Model approval mark should be there. Name or trademark of the manufacturer should be there. Model designation, serial number, accuracy class, maximum flow rate, minimum flow rate, and transitional flow rate. I told you that these three flow rates must be specified by the manufacturer. Very important one, because based upon this only the accuracy can be ensured. During accuracy test, when the a particular LMO or suppose accuracy test is being performed during model approval or initial verification or during subsequent verification, the accuracy or test on the gas meter will be performed at minimum these three flow rates, that is minimum flow rate, maximum flow rate, and transitional flow rate. So these three readings must be taken in respect to the accuracy check of the gas meter. Apart from these three readings, a particular LMO or the enforcement official can perform more tests on other flow rates also, but it should be within what? Minimum to maximum flow rates. Fine. For diaphragm meters, the flow rates which are specified for the accuracy test are minimum flow rate 0.2 times of Q maximum and Q maximum. And as I already mentioned you that the diaphragm meters are mostly used in the domestic gas meters. Now, during the testing of a gas meter for accuracy test, what system we need? So, as just before the start of my presentation, the DLM sir was also telling, and our ex DLM sir was also mentioning about the testing setup for these newly included instrument in our rule, that it is under process and very soon it will be in there in the different laboratories. And according to me, I because it is not implemented yet, so I cannot say the exact picture, but yes, according to me, these 4 points should be there. That means there should be a flow generation and control system in the testing setup. Then there should be a reference meter, that is a calibrated master meter should be there, which must be checked and calibrated by authorized agency, which will be authorized by the central government, obviously. And there should be calibrated manometers, because I told you that during the testing process, whether it is being tested for reproducibility, repeatability, or accuracy test, the rated operating condition must be ensured. So rated operating condition means the desired pressure range, the rated temperature value should be ensured. So these associated parameters should be measured by the calibrated instrument. Like pressure should be measured by a manometer, calibrated manometer. Temperature should be sensed by a temperature sensor, which should also be the calibrated one. So this is the basic setup, according to me, which is required. And now when we talk about a general flow diagram for the testing setup, so this can be a picture, not exact, but this more or less, this can be the good setup for the accuracy test, where you can see that what is there. Suppose a gas meter under test is there, which is connected in cascade with the reference gas meter, or you can say master meter. Fine. So in cascade means the gas will pass through reference meter as well as gas meter through same pipeline. Fine. And for the measurement of pressure, we need manometers, and we should measure the pressure of gas supplied through the pipeline in the testing setup continuously. Okay. And to control the flow of gas through the gas meter as well as reference meter, that at what flow rate we are going to perform the testing. So to control all these things, we need a flow generation and control system, with the help of which digitally we can be able to set up a flow rate. Fine. So suppose we want to perform the test at minimum flow rate, so we can adjust the values in the flow generation and control system accordingly. Fine. And there should be a temperature measurement system, as I already told you that it should also be there to indicate the temperature level. So this is the system through which we can perform the observations. We can make the transfer of the gas through this particular system at a certain flow rate, and we can compare the reading of reference meter and gas meter to get the percentage of error, that what is the error in the indication. Now, I'm just taking a small data just to make you understand how we will perform exactly. So suppose considering that particular flow chart I have just shown you, we are performing a test of the gas meter at a minimum flow rate, which is say 0.04 meter cube per hour. The flow rate is 0.04 meter cube per hour. And after running making the transaction at this minimum flow rate, the reference reference gas meter is indicating suppose 2 liters. However, our gas meter is indicating 1.96 liter. So we can compare these two values. So measured value minus reference value upon reference value into 100. We will calculate the percentage error. And suppose that percentage error is coming as in this case 2%. Okay, minus 2%. Fine. And similarly, we will perform the test at other flow rates, 0.2 times of Q maximum, then Q transitional, then 0.4 times of Q maximum, and then Q maximum. Suppose 5 points we have selected. So at all these 5 points, we will perform the transaction through the reference gas meter as well as gas meter under test. We will calculate the error and we will compare these errors with the prescribed tolerance. Now, whenever you will compare these errors with the prescribed tolerance, you make sure that up to transitional flow rate, the MP is different, and above transitional flow rate, it is different. So accordingly, we will compare it. Now, the next table is for the purpose of RRSLs and the authorities who are doing the initial verification, because I told you that during initial verification and model approval, a gas meter must be checked for the weighted mean error also. Okay, and it is a very useful parameter where weighted mean error is calculated basically using the formula. This formula, I told you that this formula will be used, and weighted mean error is what? It is summation of Ki EI upon summation of Ki. That means what? Suppose in our example, we have taken 5 testing points. So 5 flow rates we have decided. So this formula will be expanded for 5 terms like K1 E1 plus K2 E2 plus K2 K3 E3 up to K5 E5 and divided by K1 plus K2 plus K3 plus K4 plus K5. Now, how you will get the values of K1, K2, K3, K4 and K5? That is an interesting thing. You can see here that for Ki, there are 2 formulas are given. K1, K2, K3, K4 can be calculated is either using the relationship Qi upon Qmax, or you can use the formula K1 is equal to, Ki is equal to 1.4 minus Qi upon Qmax. So whether we have to use 1.4 minus Qi upon Qmax or we have to use only Qi upon Qmax, it depends upon the flow rate or the test point you have selected. So suppose you have selected that I am going to perform the test at a flow rate of say 0.4 liter per hour. Okay. And that 0.4 liter per hour is what? It is less than 0.7 times of Q maximum. Okay. This flow rate which we have decided, it is less than 0.7 times of maximum flow rate. So obviously K value will be calculated using Qi upon Qmax. The formula will be used Qi upon Qmax. Ki will be Qi upon Qmax. But the moment our flow rate will increase more than 0.7 times of Qmax, means 0.7 times Qmax से ज़्यादा अगर हो जाए हमारा flow rate. So in that case, what will happen? We will apply the formula Ki is equal to 1.4 minus Qi upon Qmax. So these two values we can use according to the flow rate to calculate K1, K2, K3 and K4. Fine? K4 and K5 for 5 points. And what is EI? EI is simply what? E1, E2, E3, E4, E5. E means what? Error. Error observed on the gas meter at a certain flow rate. So accuracy test, I have shown you in the accuracy test these. In accuracy test, you can see the 5 errors are calculated. So minus 2%, plus 1%, minus 1.2%. So these are basically E1, E2, E3 and E5. Okay. So these are the E values, and K values you can calculate using the flow rates. the flow rates which are specified. Okay, so you can see here that we have selected Q1, Q2, Q3 like this, up to last value is 6 meter cube per hour, and the corresponding errors are also given. So when we use these values, like suppose Q value is 0.04, so K1 will be what? 0.04 upon 6. You can see what formula we are using here. We are using Qi upon Q max. Why? Because in this case, flow rate is what? It is less than 0.7 of Q maximum. But if you will go for the last flow rate, you see when Q was what? 6 liter per 6 meter cube per hour. So 6 meter cube is per hour is what? It is maximum flow rate. And maximum flow rate is always more than 0.7 times of Q maximum. So in that case, the formula is changed now. K5 is calculated using 1.4 minus Qi upon Q maximum, and here Qi and Q max is same, so that's why it is coming as 0.4. So we have got the values of K1, K2, K3, K4, K5. We have got the values of E1, E2, E3, E4, E5. Now we can simply apply it in this formula. You can see here, okay. So K1, E1 plus K2, E2 plus K3, E3 upon K1 plus K2 plus K3, K5. When we will apply it, we will get weighted mean error as 0.69% in this particular example, and this 0.69%, if you will compare with the prescribed tolerance, you will find that it is within a limit. Fine. So this means this weighted mean error is what? It is satisfying the accuracy. So this is about the weighted mean error. Now I am reaching to the final part of my presentation, the conclusion part. And in this conclusion point of view, what I can say is that this inclusion of gas meter is really a milestone in the India's metrology framework, because as our ex-DLM Dixit sir said that in Varanasi itself, so many gas meters are going to be installed very soon, and in most of the household systems, we are going to get gas through the gas pipelines. So gas meters will be there, and they are going to play a very important role in the measurement system. Next, this inclusion of the gas meter in our rule ensures the accuracy, safety, durability, and the legal compliance in the gas meter. Okay, but at the same time, what is required? We require strict enforcement. We require periodic verification. We also require consumer protection. Okay, so this is the responsibility of our legal metrology officers, that they should apply strict compliance of these requirements. Then only we can ensure the public guarantee. Then accurate metering is the foundation of fair trade, energy conservation, and public trust. So this is another very important point in case of this legal metrology framework in our India. So this is all from my side. I don't know whether it was sufficient enough for this gas meter point of view or not. But once, as DLM sir has already promised that within 1 year, the gas meters will be installed in the regional reference standard laboratories, in IILM and other establishments. So we will be able to give the practical pictures also. Okay, so in future, we are going to learn more about these gas meter. We are going to enforce it. We are going to use it. Okay, and with this, I would like to again thank to our respected Director Legal Metrology, Ashutosh sir, who has given me this opportunity to speak, and he's a very energetic person. I even cannot imagine that this much of work how he manage, because he is always busy in the ministerial tasks, as well as so much burden he is having, but still he is always means he doesn't
Thank you,
break this
Panditji.
chain of this workshop.
Thank you, Pandit. Thank you very
Thank you,
much.
sir.
I think it is more than enough. I think this presentation was one of the best presentation we have yet. We have very few presentations which are very good. You have explained in a very well manner. What I would like to request you. Oh, thank you very much. You have, before saying you have removed your PPT. Now we can take the photographs. I would like to request the participants to kindly switch on their video and switch off their mics, please. So it was one of the best presentation. This PPT will be available on our website, on our portal. jagograhakjago.gov.in/seminars. PPT as well as video will be available maybe within a day or two, and the certificates will also be issued. My request is, Dr. Pandey, what we can do? We can make one another PPT or one another presentation, actual presentation on the test bench, so that the participant, because maybe few of us are the new one who don't know what is the gas meter, how to calibrate the gas meter. As we are all aware, it is more than, I think, 2 crores or 20 million gas meters which are already installed in our country, domestic gas meters. 20 millions, and maybe large number of commercial and the industrial gas meters, which need to be calibrated and verified. So we have to ensure that the quantity delivered is correct. With this, I would like to thank our Honorable Shri B.N. Dixit, Director Sir. I'd like to thank you, Professor Dr. Pandeyji, who has explained this in a very well manner, and all the participants. We will meet again next week with the next topic on next Saturday. Most probably we will be having another very important topic with the Professor Dr. D.S. Tiwari, who is the founder of FDES, the accreditation body in our country. So we will be discussing with him how the accreditation is very important in our country. With this, thank you very much. We will meet